All right, you guys, we're going to go over some hearing, okay? We're going to go through the anatomy of the ear, and then we're going to go through the hearing pathway. Everything you need to know step by step. So we start out, here's our ear. We have our external ear, which consists of the auricle, and the external acoustic mediatus, okay? The auricle has got those folds on it. It's meant to funnel all the sound into the ear and through the canal, external acoustic mediatus. And then in our middle ear, we have the tympanic membrane, which is synonymous with eardrum, okay? So tympanic membrane just means eardrum. This eardrum is going to vibrate, and then it's going to vibrate our malleus, incus, and stapes at the same exact time with the same frequency. These are our ossicles. And the last component of the middle ear is the oval window, which is deep to the stapes. And the oval window is going to be what the stapes pushes to then push perilymph through the scala vestibuli to then bend the cochlear duct, which we'll get to in a minute. For our inner ear, we have the semicircular canals. These canals are going to work to establish equilibrium and balance within our bodies. We'll go over that in a separate video. Then we have our cochlea. So the cochlea is where the cochlear duct is, and that's what bends to then vibrate hair cells on the cochlear duct. We'll get to all that, what all that means and what all that looks like in just a minute. And then we have our vestibular nerve and our cochlear nerve, which connects to the vestibular nerve, which is cranial nerve 8, which then takes the information to the brain. All right, so now let's go over the pathway of sound coming from the auricle and going all the way to the primary auditory cortex in the temporal lobe. We're going to go through it step by step. So we start out, we have sound waves that are going to come into the ear. And they're going to hit the tympanic membrane, the eardrum. Okay? And so this eardrum is going to vibrate. And it's going to shake the malleus, incus, and stapes. And the malleus, incus, and stapes are going to vibrate at the same time with the same frequency. And the stapes is going to push the oval window. And then step 3 is that the oval window is then going to push perilymph through the scala vestibuli. Okay? So it's going to push it all through the scala vestibuli. And then once it gets to the point where it's going to bend the cochlear duct, depending on the frequency, it's going to return back to the oval window through the scala tympani, which is just the bottom here. All right. So scala tympani is this space in here. The scala vestibuli is all of this space in here. And the scala tympani is all this in here. Now, the place where the cochlear duct is going to bend to then stimulate the hair cells is all going to depend on the kind of frequency that the sound waves are that are coming into the ear. So to explain this, if the sound waves are of low frequency, they're going to vibrate at the end, at the apex of the cochlear duct. If the sound waves are of high frequency, they're going to vibrate at the base of the cochlear duct. So now the stapes has pushed the oval window. It's moving the perilymph through the scala vestibuli. And then based on what we saw over here with the cochlear duct and the type of frequency that the sound wave is going to be, that's going to depend. So if it's low frequency, then the cochlear duct is going to bend more towards the end of the cochlear duct. If the sound waves are of high frequency, it's going to bend towards the base. All right, so low frequency, it bends at the apex. High frequency, it bends at the base. It's the perilymph that's going to do, and it's the perilymph that's going to do the bending. The endolymph is inside the cochlear duct, inside the organ of Corti, and that's just going to direct the sound waves to the specific area that the perilymph is bending the cochlear duct. So now we're going to zoom in on the hair cells because this is the next part of the signal transduction. So we have our vibration. The hair cells are going to hit the tectorial membrane. Now, once the hair cells hit the tectorial membrane, it's going to open what's called tip links, mechanically gated channels on hair cells. And once those tip links open up, you have potassium and calcium positive ions that are going to flow into the hair cell and depolarize it. So it's going to depolarize, and then it's going to fire an action potential, which is going to send neurotransmitters to then bind with the cochlear nerve, to then send action potentials down the cochlear nerve and down the cranial nerve 8 to the brain. So then we go from the hair cells to the spiral ganglion cells to the cochlear nerve. Then we go through the whole pathway that Fareed was talking about in her video, where we go from the pons, the superior olivary nucleus, to the midbrain, the inferior colliculus. Then we go to the thalamus, more specifically the medial geniculate nucleus, and then we get into the primary auditory cortex in the temporal lobe and then the insula. So that is the entire pathway of the hearing pathway.